at another example of using the mean value theorem, this time for the function f of x is equal to e to the negative 2x on the interval from 0 to 3. The first thing you want to do is state the mean value theorem, so if f is continuous on a closed interval from a to b, and differentiable on the open interval from a to b, then there exists a number c on the open interval a to b, such that f prime of c is equal to f of b minus f of a, all over b minus a. After you've stated the mean value theorem, the next thing you want to do is use the mean value theorem. So we need to first say that f is continuous and differentiable over this interval. So f of x is equal to e to the negative 2x is continuous on the closed interval from 0 to 3 and differentiable on the open interval from 0 to 3 because it is an exponential function. Which we know are continuous and differentiable over their domains. Because we've met these two hypotheses, there exists a number c on the open interval 0 to 3 such that f prime of c is equal to f of 3 minus f of 0 all over 3 minus 0. Once you've stated the general mean value theorem and applied it to your function, the next thing you want to do is actually find the values of c that satisfy our conclusion. In order to do that, we have to actually figure out what f prime of c needs to be equal to. So we have to find f of 3 and f of 0. F of 3 is equal to e to the negative 2 times 3. So that's equal to e to the negative 6. F of 0 is equal to e to the 0, which is equal to 1. So that means that f prime of c is equal to e to the negative 6 minus 1 over 3 minus 0, which is 3. I can write the 3 minus 0. Now we have to find the derivative of our general function, f prime of x is equal to, well, we have to use a bit of chain rule here. So we have an e to the negative 2x, because the derivative of an exponential function is still that exponential function. Then we have to take the derivative of the inside, which is that negative 2x. The derivative of negative 2x is negative 2. So the derivative of our function is negative 2 e to the negative 2x. And we're interested in where that is equal to e to the negative 6 minus 1 over 3 minus 0, which is again just 3. Now we need to solve for x. So I'll start by dividing both sides by negative 2. So we have e to the negative 2x is equal to e to the negative 6 minus 1 over negative 6. Then I'll take the natural log of both sides. So that means that I have negative 2x is equal to the natural log of that entire e to the negative 6 minus 1 all over negative 6. Dividing by negative 2, I have x is equal to negative 1/2 times the natural log of e to the negative 6 minus 1 over negative 6. Applying some properties of logarithms, we get that x is equal to the natural log of the square root, and I'm actually going to write this over here where I have a little more room. So x is equal to the natural log of the square root of, so that's the 1/2 part of it, then I have to find the reciprocal since it's negative, so that's 6 over e to the negative 6 minus 1. Since this is only one number, we don't have any plus minuses here, that means that this number is c. Since by the mean value theorem there has to be at least one number c that satisfies this condition, and we only have one number, we don't have to check to see if it's in our interval. It must be.